June 19 International Paper 1 Question 15. So we've been through parts A, B and C, so this is just part D. So let's have a look at part D. At t 0.7 seconds the trolley moves onto a piece of horizontal sponge. The trolley comes to rest after moving through a further 0.25 metres. So what this is getting at is that the trolley's got kinetic energy, it's moving, and then it comes to a stop. Basically work is done by friction, so you're trying to work out that force. So while it's moving we've got kinetic energy at a maximum, and then when it's come to a stop the kinetic energy equals 0. And why has that happened? Because the work has been done by friction, and the amount of work that's been done is going to equal the force, or the average force, and the distance. And being that the question has told us we've got 0.25 meters here, that's your distance. So let's see what we need here. We're going to use, for the kinetic energy while it's moving, half mv squared, and that's going to equal the force applied multiplied by the distance. And when you substitute the values in from the little graph, the kinetic energy is going to be 0.288 joules, and that's going to equal the force times 0.25 meters from the question, and that comes out, that shows that the force is equal to 1.15 newtons. Okay, now the next part of the question is explain how the acceleration of the trolley down the ramp could be determined experimentally using ICT. Right, so most people failed to access marks here because you just said generally use light gates, use a data logger. But they want you to be specific exactly how you're going to do it. So basically it's going to be something like this. You're going to have a slope, and you're going to have a trolley going down the slope. And the way we normally use it is we'll have two light gates, and as the trolley cuts through the light gates, the length of the piece of card that's going to cut the light gates is a known length. So we can get the velocity through the first light gate, we can get the velocity through the second light gate in the same way, and if we know here the time between the two light gates, we've got everything that we need to work out the acceleration, because the acceleration, we would use the equation v minus u, but let's write it like this: v2 minus v1, so that's the change in velocity divided by the time taken. So you have to describe this basically to get the 4 marks. So it would be something like two light gates connected to a data logger. The light gate records the time for this known length to pass and uses that to calculate the velocity. Same thing at the second light gate, and the data logger also will record the time between the two light gates, and then we can use A equals v2 minus v1 over t to calculate the acceleration. And you'd have to make all of those points to access the 4 marks. And that's the end of this question.